Good morning, everyone. I hope you all are doing well. So let me introduce myself first. My name is Monolithic. I'm working as a .NET developer in Yudiz solution. And today is my co-host. Along with me, today's my co-host is Durga Bhimani. She is also working as a .NET developer in Yudiz solution. So on the behalf of our organization, I'm warm welcoming you guys and thank you so much for joining our meetup. So now, before I talk about our today's agenda and introduce our today's speaker, I would like to know how many of you have worked on microservices? Anyone have a little bit idea about microservices? Just raise your hand so we can get some ideas.
Yes. Kinal Patel, Hitesh Kumar, Prasad Kumar.
Yeah.
They have idea about microservices.
Yeah, thank you guys. Quite small number of amount, but not a problem. Those are already aware about the microservices. They will get some more clear idea about the theoretical manner. And those haven't any idea about microservices, that get some initial phase or initial starting points of the microservices, that how they can start. Okay, so let me go through the today's agenda. Today we are going to differentiate today's our agenda in the mainly two parts. There are the main 4 points that will be covered in the first part, and that part will be covered by our first speaker, Divya Trivedi. She is working as a .NET developer in a Yudiz solution. So these are the 4 points that will be covered by Divya. First will be what is microservices. Second, architecture of microservices. Third, why we need microservices with .NET, and at the end, next decade of microservices. Afterwards, the second part will be covered by the Pradeep Kumar Yadav. He is also working as a .NET developer in Yudiz solution. So these are the 3 points that will cover by Pradeep. First will be difference between monolithic versus microservices. Second, what is gRPC and why we have to use gRPC. And third, at the end, we will cover use of Docker with the microservices. So now, without wasting more time, I would like to hand over this session to the Divya Trivedi. Yes, Divya, over to you.
Hello everyone, good morning. I am audible to all?
Yes, Divya.
Yes, Divya.
Yes.
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 Thank you for the knowledge. As Manharsi introduced me, I am Divya Trivedi working in a Yudiz solution as a .NET developer. So our meetup's today's topic is what is microservices. So from the audience, have any idea about what is microservices? Can anyone say? Okay. Okay, not an issue. Let's see what is microservices. So microservices are small modular and independently deployable services. Understanding of this, we can say it if we are creating any large scale of application. So we can divide our application on a different modular or different services. So it will be deployed in any server. So it work independently. It means we can host our environment, our services in a different environment. For example, one service host in a one environment, that is port number 5051, and another service we will host in a 5052. So it will be work independently in its own way. So that is the microservices, and each microservices lives independently, but on other hand also all really on each other. As we discussed that each microservice lives independently because they are deployed in its own environment. But on other hand, it's all really on each other. How it is? Because there is the different services. So understanding of this, we can understood through the example. For example, we are going to create any large scale of application. For example, eShop project. We are going to create a eShop project. So what happen on it? So first of all, need to planning for it, and because there will be a many functionality will be available for there. So need to divide our whole project in a services for a modular. So there will be a customer management on a eShop project, as well as customer searching for any item, that will be a basket service. We can say that is the basket service. And if customer order any item, so that we will store all the ordering related item, there will be in a ordering service. And for example, if customer buy any item, so it will be next process is the payment process. So will be payment for it. So that we create a payment services. So in a identity service, here is the all customer management are be there. And in a ordering service, or customer order for any item, there will be managed in a ordering service. In a basket service, there will be store any item or remove any item. So how it is connected with each other. For example, customer can search for any item. So that item is available on basket or not. So it need to connect, it send a notification to the basket service that customer can inquiry for item is available on basket or no, not. If the item is available in basket, then it notify back to the identity service. So each service is a communicate with each other. So it's depends on each other, we can say it. And we can also store all services in a different databases. All microservices in a project get deployed in a production at their own pace, on premise, on cloud, independently, living side by side. As we discussed earlier, that all microservices live independently because they are hosting in a different environment, living side by side. And that's all. In that, anyone have any doubt?
I have one doubt.
Yes.
How two different module will talk with each other?
It using a event bus connection or using a gRPC connection. There will be discussed in our next part, in our next topic, that how it communicate with each other. Okay. So let's see the architecture of microservices. In a architecture of microservices, here is the client application. In a client application, there will be a web application, web SP application. It means which type of application or website we need to create. That will be we are creating. For example, we need to create a website on a Angular, on a HTML, on a Blazor. That we create a website on it, and from the website, it call the API gateway. Here through it's called a API gateway. In a microservices project, there will be a single API gateway. We can also use the multiple API gateway for the call the services. So here is the use single API gateway. That API gateway through it's called the services which need to call. For example, any client can inquire, any customer can inquire for any item there is available or not. So it call a particular service which need to call. Here is the basket service which need to call, because in that service item will be stored or deleted, that will be adding. So it call only particular service which need to call from the API gateway. And here all are the services, and different services store in a different databases, or we can store in a same databases. But we can divide, we can store our services on a different databases as our need. Here is the no database dependency, because for example, we need to here we can define how database, which database we need to select. For example, in a basket API, there will be a item. For example, any one item added in a basket service, so it will be even there, but per customer buy that item, so it will be delete from that. So it is a temporary data on a basket API. So we store that API on a Redis database, because Redis database will use for a store of temporary items. So we can use use database by our needs. So that is all. And here is the connection, how one API connect through the another API. Communicate with another services, so that we use the Redis. Here it's a user RabbitMQ, or also we can use a event bus as well as a gRPC connection. So if we talk about the event bus, how it's communicate one service with another service. So from the event bus, there will be event bus 2 method, publish and subscribe. So publish means sender, and subscribe means a receiver. For one service is send any request that can be publishing, and another is receiving the any item, that is the subscriber. So we need to, from the event bus, we handle it all. And also it's a gRPC connection or a RabbitMQ connection. We use as a mediator for connect one service to the another service. So in that, anyone have any confusion?
So I have one confusion is like, let's say if we have the catalog API over there, right? And if I
Yes.
want to call the some orders data from the catalog API, I am going through the RabbitMQ, or just I'm calling the ordering API directly from the catalog API.
You can also call directly from the catalog API to the ordering API using a gRPC connection. There will be a gRPC part. So gRPC client and gRPC server communication is be there for a connectivity, but other, we can say other mediator are that is a RabbitMQ or event bus, or many other are available for that.
If the RabbitMQ is there, as you said, like there is a sender and there is a publisher, right? So catalog will be the publisher and the order will be the receiver.
Then,
But how will I get the data back using that method? Like if I ask for some data, it is just like the posting the events, and the required part of that publisher will execute, right?
yes.
RabbitMQ will not return the data basically.
Actually, I'm not talk about RabbitMQ. I was talk about the event bus. Here it use a Rabbit bus, but we can also use a event bus. In event bus, there will be a two method. There is a publisher or subscriber. So in a event bus, there will be a two method, that a publisher or subscriber. So publisher can send data, and from the subscriber, it's receiver data. That means event bus, we create an event bus. There we need to host in any cloud. For example, we can host in a Azure server, and we can communicate each service with another service using pop-shop method. It's the pop-shop method.
Okay.
Okay. So any other confusion to anyone? Okay.
To write down your question in chat box as well, if you want.
Yes. So our next topic is why we need microservice with .NET. So with .NET, .NET support the microservices library, and .NET 6 version. Currently, .NET 6 is using supporting a microservices. So let's see how it's work. It's a microservices. So microservices with .NET using a continuous delivery. Each services reside in a separate container along with environment it need to run, because every services is running store in its own environment. So which service need to call, only that service are going to call. No need to change on any other services. So it's a deliver in a continuous manner. Next is a maximize deployment velocity. As we discussed that all services are reside in a separate container. So which service are going to change? For example, we can change in a one services, that is a basket services. So only deploy that services at a time. Basket service need to deploy. So we can it's not a time consuming, because there will be not need to publish all the services at a time. We change in a particular service, so need to publish only that. So it is the not a time consuming, and that speed high. Then faster innovation to adapt to changing a market condition. Microservices allow application to be updated and tested quickly. So it's adapt faster innovation, and also developer can experiment on application without fear, because there will be a different services. For one developer can change on any one services for its experiment. So it can do easily, because no need to change on any other services. Then enable developers. Why it's enable developers? Because when we talk about the structure of the microservices, it is the some high structure, because there will be many connection are there. For example, one service to another service connection, then service to API connection. So need to enable developers mind are present there. So we can enable one developer for one services. So it easy for a developer as well as our product too. And cross-platform capabilities. If we talk about the cross-platform capability, so it is the main benefit of microservice is not to be attached in a specific language or a platform. It will be compatible with Windows, Linux, Mac OS, or etc. Platform compatible with microservices. Then containerization. In this, we can say we use containerization. For the containerization, we use a Docker. In a Docker, we publishing a services, different services in a Docker container. So Docker container is a support in a .NET with a microservices. Then command line oriented. Understanding of command line oriented, we can say it easy to create, manage, compile, run and deploy services from the command line. We can perform all the operation through the command line, and it's support in a .NET. Then easy to start. In easy to start, we can say there will be a not need to for example, from the Visual Studio, we start developing a microservices. Need to select a web API project from the Visual Studio and start creating services, or as well as a API gateway. It's easy to start to creating a microservices project. Then a stability. With a .NET, microservices are working stable, and .NET support all the library of the microservices, and its modular performance has improved greatly, and platform is a much better and more stable overall. So in IDE, we can say here is the no need to use only one IDE. For example, we are creating a microservices in a .NET, so no need to use only Visual Studio. It will be compatible with any other IDE. For example, we can also use a VS Code. Then Kubernetes. So in a Kubernetes, anyone have any idea about what is Kubernetes and how it's work?
No.
Okay. So Kubernetes, understanding of this, we can say Kubernetes is a portable, extensible, open source platform for managing a containerized workload, and that service facilitate both declarative configuration and automation. Containerization, that means we use a Docker support with the Kubernetes, and .NET Core is a completely compatible with Kubernetes 8. So we can take advantages of all its feature and scale our application, scale our microservices easily. Then reduce cost. How it's reduce cost? The main question is there. Because if we follow the monolithic architecture and the microservice architecture, there will be in monolithic architecture. First of all, we need to deploy a monolithic architecture. It's not a high cost. It will be a reduced compared to microservices, because there will be only a single project need to deploy. In a microservices, there will be a different services need to deploy. But in a future, have its reduced cost, that in monolithic all part interact with each other. So for example, we create an issue project in any festival, the traffic in our website is a high. For example, we create in a monolith application in a monolithic. That time need to buy any, because there will be a many requests are there, so need to buy any server, or need to add any GBs on that server. So in a monolithic, there will be a high cost, but in a microservices, there will be if in any festival there will be any high priority or a high request are there. So we can use the only that services. For example, there will be issue project. There will be any offer on a Diwali special festival. So need to publish only particular services which are going to request fast at that one time. So that is the reduce. And In that, anyone have any confusion?
No.
If you have any doubt, you can raise your hand, and you are also able to write down in chat as well. So please be free to ask questions.
Okay.
Yes, you
So,
continue.
So our next topic is the next decade of microservices. This is the survey from the modernintelligence.com that cloud microservices market was valued at USD 830.31.45 billion in 2022. It expected to reach USD 2,701.36 billion by 2026. It approximately 21.7 over the forecast period 2021 to 2026. So obvious it is the great change on a microservices that from 2021 to 2026. And there is an incrementing demand from North American companies as they adopting a microservices architecture in many areas, in a finance areas, e-commerce and traveling and many other areas are there. As we talk about India, one of the top company from India is a TCS is recently adopted microservices, and we talk about another out of the Indian company. There will be a Amazon. Amazon is a moving on a microservices, as well as a Spotify, eBay. Those famous companies are moving on a microservices. So we can talk about by enterprise size. So there will be a small and medium enterprises are using microservices, as well as large enterprises also moving on a microservices. By deployment mode that we talk about, it's a platform independent, and there will be a many services that in a deployment mode. Then by end user industry, there will be a retail, manufacturing, IT, e-commerce, healthcare, and many other companies are industries are using a microservices or moving in a microservices. And by geographics, North America, Europe, Asia Pacific, Latin America, Middle East, and Africa are moving on a microservices or adopting a microservices. So in that, anyone have any doubt?
No. No.
So that's all from my side. Thank you.
Thank you so much, Divya, for sharing knowledge. Now, anyone have any doubts till now, then you can ask. You can write your question in chat box as well. So I think we should need to take a break. So what about we play game, Manhar?
Yeah, good. That will be great.
Okay, so let's play Kahoot quiz game. And for that, please Manhar guide our participant to how to play this game.
Yes, sure, good. So before I talk about some guidelines, anyone have played Kahoot? Anyone have an idea how we can play a game?
No.
No.
Okay. Before we move to the game, I think one person have a question.
Sorry.
There.
Yes.
Yes, Divya.
How do
The question is
microservices
how
are
to
connected?
microservices are communicate each other.
Yes. How to microservices are communicate? Understanding of it, we say that connect one service to another service using gRPC connection, as well as the event bus, as well as the RabbitMQ. That is the mediator to connect one service to the another services. And we talk about the event bus. There will be it's a pub/sub method that used for one service to another service connection. For example, from the publish method, we can send any data, or from the subscription method we can receive any data. Yes, Kapta is also there. Kapta we also use for a Kapta. and there is the compatible with yes. It's okay.
Okay, so anyone have any other questions, or we should continue the game? I think no one have any question for now, so we can continue.
Yes.
So game is very simple. The things that you have to do is one link and one code will be shared by Durga in chat. You have to just go through that particular link. Once you go through that link, you have to enter your PIN that will be shared by Durga in the chat box. Afterwards, you have to enter your name. Once you connected to the game, the questions and the options are you are able to see in the screen, in our screen. Now the thing is that I will recommend that use the second another device so you can get clear, you can enjoy the particular game. Otherwise, if you use the same device, you have to move your tabs at a time. So that will be a little bit difficult for you. So once you enter the game, the questions and the options will be you are able to see in the screen. And the coding, through the coding matching, you have to choose the option from your screen. And after once the question you answer the question, you will get the leaderboard as well. That how many points you get. So let's we start in between. If you have a doubt, you can raise your hand or you can write down in the chat box as well. So I think Durga have shared the link in chat box. You can go through that.
Yes. And the game code is 7363427. So be ready.
So the first question is, what do you mean by microservices? And these are the four options.
Nice.
Independently deployable, dependent deployable, non-maintainable, different services using the same database. Okay, so there are the 12 people, they have choose correctly.
It is on top.
Yeah. One service cannot communicate it with another service. True or false?
False.
Okay, so there are the 16 people, they choose right. Pratik is on top. One service communicate with another service using Docker, Kubernetes, event bus, or none of these.
Event bus.
Okay. Yeah, there are the 16 people, they have choose correct option. Great. Pratik, Kinal, and Aman are currently in top. Fourth question is, one API gateway connect with many services, true or false? Okay. There are the 19 people, they have choose correct answer. Hinal, Pratik and Aman is still in top. Fifth is microservices capable with a dash platform, Mac OS, Windows, Linux, or all of the above. Yeah, all people have choose correct option. Great. Siddha have a streak of 5 correct answers. For creating microservices with .NET, which project need to select from Visual Studio? Blazor WebAssembly, Web App, Web API, or the core empty? Okay, 13 people have chosen correct answer. Hinal, Aman, and the no fill in highest position for now. Now, last question is Redis cache database using for temporary data store, permanent data store, read-only data store, or none of these?
permanent هم میشه استفاده کرد، معمولا temporary data store.
Temporary data store. So here is the winners. Okay. So Hinal Patel is in the first position, Aman in second, and the Siddha is third in. Yeah.
Okay, thank you, Manhalsi. And thank you all the participants as well. I hope you enjoyed this game. Okay, so back to our main agenda. Our next session will conduct by Pradeep Kumar Yadav. So I would like to hand over this session to Pradeep Kumar. Over to you, Pradeep.
Good morning, all. First of all, I want to thank Manar Singh Jadeja and Durga Bhimani and my organization and my colleagues who chose me to share my knowledge and experience related to microservices. So, as Durga introduced me, myself Pradeep Kumar Yadav, and I am working as a .NET developer. So, here I will explain about the differences between monolithic and microservices. Am I audible?
Yes, Pradeep.
Yes, Pradeep, you are.
Yes.
So here is the slide. We have two images. One is for monolithic and another is for microservice. So from audience, can anyone differentiate it based on the given images?
I think no difference.
Yeah, one difference
Difference
is
in the line.
they all are in one environment and others are independently kind
Okay,
of there.
anyone else?
No difference in image.
Okay.
I am briefing something about. If you can see, first image figure is telling us about monolithic applications. Here you can see all the functionalities of a project exist in a single code base, in a single application, and in the second image is telling us about microservices. Microservices are the small services that work together, and it is an architectural development style in which the application is made up of smaller services. They communicate with each other directly using lightweight protocols like gRPC. and all are independent in hosting. Right? So next point is architectural differences. So audience, so what is the understanding from this slide? Can you contribute with me?
Anyone?
Hello. What are you understanding from this?
Yeah, so in monolithic architecture, you can see the user interface is directly communication with business logic and then database. So there is only one-to-one communication. And in microservice, user interface can communicate to any of the microservice, like any of the APIs. So that is in every microservice is independent there. And
Yes.
every microservice has its own database independently.
Yes. So let me brief about it. So what we do in monolithic, we have a problem statement and where we ask to design a system with various functionalities. Now in monolithic, we design our application in various layers like user interface, business logic, data interface, and database. So in user interface, we cover our user interface like UI, and in the business logic, we cover our services, functionalities, methods, and in data interface, we cover our database connectivity and data models. So in database, we store the data. But in other hand, in microservice architecture, as I briefed about microservices in previous slide, microservice is a small services and they communicate each other. So in microservice architecture has a significant impact of the relationship between applications and the database. In microservice, instead of sharing a single database with whole application, here each microservice has its own database. It often results in duplications of some data in some cases, but having a database per microservice is essential if you want to benefit from this architecture, as it ensures loose coupling. Another benefit of having a separate database per microservice is that each microservice can use the type of database best suited for its business need or for best suited for its particular service. I hope someone asked the same question. Which type of database we can use in the microservices?
I think Salman has some question. He raised his hand.
I just wanted to ask, like, if all the microservices is all different databases, then there could be some data consistency issues, right?
Hello?
Hello, am I audible?
Yes.
Yes.
Yes, so I wanted to ask if all microservices has their own DBs, so there could be some consistency issues, right? Data consistency issues. Or in some cases, some microservice may read some dirty data or something. So my question is, how do we handle that? That's it.
Okay. As I already explained, each microservice has its own data. Sometimes it's raise duplication, okay, but it responds directly to user interface, not to services. Sometimes it's internally connect. If they share same data, they need to share internal data, so it doesn't lose coupling, so it doesn't conflict with each other.
Anyone else? I think no one. You can continue, Pradeep. Hello, Pradeep.
Previous okay. So next is the scalability. So can anyone let us know what is meaning of scalability?
Sorry to interrupt you, Pradeep, but Rohit Kumar has question like, What is microservices design patterns?
Microservice design pattern. Have you seen the in first session?
Rohit, you can unmute yourself and ask your question.
Hello, am I audible?
Yes.
Yes.
Just wanted to know what is actually the microservices design patterns. Actually, I just joined after 11:15, so don't know if anyone explained before.
Okay. Can you go for the previous slide? Yes. So here is the architecture architecture, my microservice architecture. So each microservice have a yes. This is the microservice design patterns. Means we can divide our functionality in different services. From the image you can see we have an e-shop application, but we have a different functionality like catalog, basket APIs, discount, and ordering APIs. So we differentiate our all functionalities in different microservices, and they communicate each other by using any lightweight protocols like gRPC or REST APIs, Kafka. And internally, it's like other services. We design our other services. No changes in syntax. Changes in the only architecture. Creating a different service applications for a single application.
Okay. Got it.
Okay.
Thank you.
Rohit, I think you get the answer of your question, but if you haven't, don't worry. At the end, if time permits, team will go through the coding example as well. They will show the one coding demo. At that time, might be you will get some more clear idea. So don't worry about this.
Okay, sure. Thank you.
Yes, Pratik.
So can anyone let us know what is meaning of scalability? Not in technology, just in normal term.
Scalability means if somehow users are increased, so how well our system can increase or decrease the resources to meet the performance.
And
Yes.
one more point about the scalability is like if our enterprise application have the first limited module, and later on if we need to introduce the different modules, like we just start with the orders and basket, then we need to add few more modules, billing, invoice, and everything. So in terms of that, we can also consider as a scaling of our application in terms of functionality.
Okay. Let me make it easier. It describes a company or software's ability to grow without being hampered by its structure or available resources. Means we do not need to extra resources if we have a more requirement of production or more requirement of responses. So at that time, you do not need to add extra resources. Okay. So in monolithic applications, back. Okay. In monolithic applications are difficult to scale up once they get larger applications. We can create new instance of the monolithic and ask the load balancing to distribute traffic to the new instance. Means we need to deploy the instance of whole application in multiple servers. So it is the disadvantage of the monolithic applications, because sometimes different components have different resources requirement. One might be CPU intensive, or sometimes others may be memory intensive. So monolithic architecture, we cannot scale each component independently. But in other hand, in microservices, scalability is the major advantage in microservices architecture. Each microservice can be scaled individually. If a particular microservice is facing a large load because of a user using that function, in access, then we need to scale out only that microservice. Any question from this slide?
I think no one.
Next is time to market. So for starting, I want to let us know you what is time to market. So time to market means the length of a time from the concept of a product until it is released to the market. So Monolithic is complicated and also time consuming because it becomes too large in size with the time and hence difficult to manage. We need to redeploy the whole application even for a single small changes. As the size of applications increase, its startup deployment and time also increases. And it's also complicated for the new developers. It is very difficult to understand the logic of a large monolithic applications, even if his responsibility is related to a single functionality. Because in the monolithic applications, all the services are mostly connected to each other, so they are not independent. So at that time, before working on any service, we need to understand for the logic of the monolithic applications. But in the microservices, it's easy compared to monolithic and also easy to deploy because it's a smaller in size. If there any update in one of the microservice, then we need to redeploy only that microservice. And microservice is self-contained and hence deployed independently. So their startup time and deployment time are relatively less. Yeah, but if you are first time hosting a microservice application, so it take time because you have a multiple microservices. Not take time, but it's complex to in hosting. But once you hosted and we need to changes, then that time we can save our time because we do not need to host a whole application. We just need to host particular microservice which we added new or in which we make changes. So it's a very easy and also it's very easy for new developer to onboard the project as he need to understand only a particular microservice providing the functionality. He will be working for and not the whole system. So any question from this point?
What is microservice, for example, for sending OTP for verification and use it in my post API command? Is it called a microservice?
Can you repeat?
Okay, Vashisht, can you please unmute yourself? Okay. What is microservice, for example, for sending OTP for verification and use it in my post API command? Is it called microservices? I think Khaja give him an answer.
I think he get the answer.
Okay, no issue. Still any doubt, then you can ask again.
Okay.
Okay, you can continue.
Reliability. Monolithic applications are not a single bug. Any module can bring down the whole applications. But in other hand, in microservices, it's much reliable because if a particular microservice goes down due to some bug or reasons, then it doesn't affect other microservices and the whole system remain intact, safe, and they will continue providing other functionalities to the users. And as soon as possible, you can fix that issue and immediately deploy it. So for example, if you are taking as ESOP applications example, assume applications ordering or payment service is down. So at that time, what you can search for the product, you can add it in your basket to the product. So this functionality will be working continuously. And but in a monolithic, if you assume any network issue or a database connectivity issue, so whole application will be goes down because there is a single database and single deploy host. But in microservice, individual database for each microservice, so it will work to fine. Any questions from the differences from audience sides?
Hello, can you hear me?
Hello. Yes.
So what I understood on based on reply is microservice is a service which inherits the main service, right?
Inherit, not in multiple services. Hello.
Yes, I think I mean for error handling purposes, if anything wrong goes wrong in one service, another service starts.
Yeah, if one service is down, then other service will be work finally. It doesn't bring down whole application down. It does only bring down that service down. Any more question?
Anyone else?
I think no one, Pradeep. You can continue.
Okay, so next. Our next point is what is gRPC and why we have to use gRPC. So, anyone have you ever heard about gRPC? Okay. Someone have a question of how microservices communicate with each other. So we have one solution. It's gRPC. gRPC is an open source. First of all, gRPC stands for Google Remote Procedure Call, because it was developed by the Google for internal use, and gRPC is a robust open source framework used to build scalable and fast APIs. It allows the client and server application to communicate transparently and develop connected systems. So in microservice, we have a multiple services, so they can communicate with each other, or we can also be not in only microservice, we can also use in our other applications gRPC, because it's exchanging the message in binary format, like REST API. We have it send a service message to the user interface and take a request from user interface and send to the service. Same is also gRPC, but it's faster and secure to REST API. And nowadays, many leading tech firms have adopted gRPC, such as Google, because first of all, it's also by Google, so Google already using it, and other companies are like Netflix, Square, Cisco, etc.
Pradeep? Sorry for interrupt.
Hello.
Hello. Yes.
Hello.
Hello.
Mm.
Am I audible? Yes. Someone has question like Kafka can be alternative.
Yes. It's also because there's a communication protocol. Okay. This is the gRPC communication type. First is the simple RPC, also known as the unary RPC. This is the simplest communication pattern by gRPC. Here the client sends a single message to the server and receive a single message from the server. And the next is server streaming. And that unlike in simple RPC pattern, in server streaming RPC, the server sends back a sequence of responses when a request is received from the client. This sequence of responses messages are sent inside the same HTTP stream initiated by the client. The server waits until it receives the message from the client and send multiple messages as framed messages. At the end, the server concludes the stream by sending the trailing metadata with call status details. Any question from this unary and server streaming? So next is client streaming. Client streaming RPC, where the client writes a sequence of messages and sends them to the server. Again, using a provided stream, like in the server streaming. Once the client has finished writing the messages, it waits for the server to read them and return its responses. And again, gRPC guarantees message ordering within an individual RPC call. And the last one is the bidirectional streaming RPC. In this bidirectional streaming RPC, both the client and server send a stream of messages to each other. And the client sets up HTTP stream by sending header frames. Once the connection is set up, both the client and server can send messages simultaneously without waiting for other to finish. And the communication happens based on the logic of the gRPC client and server implemented. For example, any question from this? So this is the image in that we have a how gRPC we connect.
Sorry
Is
to interrupt
Microservice-
you, Pratik.
Yes.
Salman is asking about the example. Salman, if you can unmute yourself.
It was about communication types, like some layman example would be very good.
Okay. In bidirectional or okay, in any, let me contribute. So in like if you are sending for a request, like you are passing the ID, sending your ID as a request, and want to get all the detail about that particular ID. So it's same like we have a request in the other API communication protocol. So no difference, but in bidirectional, it's faster and simultaneously because it supports HTTP too, and HTTP used to use better network latencies. For example, the server could wait to once the connection is established in the between the server and client, then after that they can continuously send to the responses and continuously accept the requests. Hello.
Salman, you get the answer of your question?
Yeah, little clear now. Okay.
Yes, Pradeep, you can continue.
Next. So this is the how gRPC we implement gRPC in our microservice projects. So first is the our user interface of the HTTP one, our normal browsers, and after that from the user side we send the request. It go to the API gateway, and in API gateway implement gRPC client stuff, and it will deserialize the requests and send to the server side. And server run on the HTTP to internally communicate with each other. And a gRPC server can be also the gRPC client for the gRPC server. So it makes faster, and it's on it's in binary format, so it's a much faster compared to other message formats. Any question from this image?
Pradeep, Deepak has question like any limitations of Kafka to publish items?
What?
Any limitations of Kafka to publish item?
From audience, can anyone contribute for this point? Hello.
Yes, Pradeep, you can audible.
Hello.
Yes, anyone from audience want to answer this question? If you want to write down in the chat as well.
So let me make it because Kafka is like other PubSub messaging system. Like we have an event bus, we have also PubSub, and Rpc is the working on the binary format, so it's machine readable, so it's the fastest, and that's.
Yes, Pradeep, you can continue.
Okay, next. So this is the Rpc design. How Rpc work? So in Rpc, a client application make a local procedure call to the client stub containing the parameters to be passed on the server, and the client stub serialize that parameter, and it will set to the client stub client library. And once the client library gets this message, it will send to the server side library. And again, server side stub will be unpack that serialized message, and then once action completed, then it will return to the client. This is the how Rpc work. Okay. Here is the from how we start to is. So first is the flow start with creating a gRPC server application and define a service definition file called as .protofile. It's a high level description of service export and what are methods on these services. And once we created the protofile, we will generate a server side and client side stuff from the with the compiler. Once we completed generate the file server and client stuff, we will implement the server in one of the supported language. It can be any language like Java, C#, which will be best for that, which will be we are using for that particular microservice. And once implementation complete, we can run the server and client applications both. So here, as soon as the client invoke the service defined within the protofile and request to the port where the server is running. The service implementation at the server side get invoke and return the data in binary format, which will be further deserialized to the response object that is defined in the configuration file protofile. Once the client call a stub method to server is notified that the RPC has been invoked with the client's metadata for this call and the method name and the specified deadline if applicable. And the server can either send back its own initial metadata like connection established or etc. or wait for the client's request message, which happens first at application specific. Once the server is the client's request message, it does whatever work is necessary to create and populate a response. The response is then returned if successful to the client together with status details. And status details, it may be status code and optional status message and metadata of the particular RPC call. So this is how the RPC work. Any question from this point?
No.
Everyone, I profile.
anyone have a question regarding gRPC? You can unmute yourself, and if you want to write down the question in the chat box as well, you are open for this.
Okay, so before go for the example, first we need to, I will tell you about what is protocol buffer, protofiles. So protocol buffer or protobuf is the Google serialization deserialization protocol that enables the easy definitions of services and auto generations of client libraries. And gRPC uses this protocol as a dear interface, definition languages, and the serialization toolset. Its current version is Proto 3, as I written in syntax Proto 3, which is the latest feature and it's easier to use. And the gRPC services and messages between client and services are defined into protofiles. The protobuf compiler ProtoC generate client and server code that loads the protofile into the memory at runtime and use the in-memory schema to serialize and deserialize the binary messages. After code generation, each message is extended between the client and remote services. And parsing the protobuf requires fewer CPU resources because the data is converted in already in binary format and encoded messages are lighter in size. So messages are extended faster even in machines with slower CPUs like mobile application devices. So this is our gRPC protofile, and that first line specifies the version of protobuf used in this particular program. This is the Proto 3, and second was the namespace under which this service will be created. And after that we have package name, and after that we have a next section specify the actual service name and the method into the services. In our case, our service is greeter and method is the say hello with a hello request message, and it return to the hello reply message. And the last section is actual data which will be written from the services. They like a hello reply. So any question from the syntax of the protofile?
I think no one will.
Okay. So next. Okay, this is the implement. Once we are done with adding the protobuf file, we are ready to create the server. In this server, we will use the automatically generated code from the protobuf file. Like we have a greeter service. So inside that greeter service, you have another class known as the greeter base class for the server side, and we have also another class known as the greeter client class. And after that, we implemented for that particular microservice, particular method which we defined in the protofile, sending a message with a hello and get the request from the client side. Like if we send the ABC, so it will respond hello ABC. Here one question: if there is a multiple request and responses, then we need to create protofile for each. So multiple request response in which scenario? Like for a particular method or different methods. Hello, Rohit.
Sorry to
Yeah,
interrupt
actually,
you, Pradeep,
if
but
I
those questions, if you may unmute yourself and ask.
hello.
Yes, please.
Yeah.
You can ask.
Okay, so what actually, if I have a service which is taking something as an input and providing something different in output based on the request. So, do I need to create a separate protofile for each of the response, or it will be manipulated accordingly? Like,
You can manipulate it. Like if you want to keep some can we go for the previous slide?
Yes, Rohit, you can create many services in the one
Okay.
protofile as much as you can maximum. There is no any kind of limitations where you can not create you can create. But what we do is whenever we go for a microservice, we try to keep our code separated. So you can create a different protocols for set of same services, right? So for that purpose, you can create different protocols. But yes, we can create as much as many services in the one protocol.
Okay, okay, thank you.
Yes, anyone have any other question? Okay, you can continue, sir. Thank you.
So next point, why we have to use gRPC? So also someone asked me about if we have Kafka or other, so why you are using gRPC? So let me clear about it. So first point is like its performance. gRPC offers up to 10x faster performance and API security than other like REST plus JSON communication, and it uses protobuf and HTTP2 protobuf serialize the message on the server and client sides quickly, resulting in small and compact message payloads. And HTTP2 scale up the performance ranking by server push, multiplexing, and header compressions. And next is the streaming. gRPC support multiple type of streaming, like we seen previous slide, unary client to server streaming, server to client, and bidirectional streaming. And it's also support code generation, so we do not need to write the class for the serialize, deserialize or other. Just we need to create a protofile and compile it. It will generate base class and inherit that base class in your server implementation. And it's also provide the end-to-end encryption, so it's also provide high security. Anyone have question why you have to use and it's also reduced network latency, so because it's running on the HTTPS2, so which allow for faster and long-lived connections. Once connection is established, it doesn't down for after one single individual request response. It will be so any question from the gRPC from audience sides?
I think no one, Pradeep. You can continue with Docker.
Okay. First, before going to use of Docker with microservice, first let's clear what is Docker. So from audience, have you ever heard about Docker or any idea what is Docker? If you have idea, please share with us.
Anyone from audience? Guys, we are here to discuss with you, not teach you. So please be interactive.
Yes, so Docker is basically
Docker is right down in a chat. Yes, you are also. Yes.
Yeah, can you hear me?
Yes, can.
Yeah. So Docker is basically to containerize your application. So you can create your Docker container and host your applications or microservices in separate container. So then, what will Docker container will? So Docker container will take your complete package of your one service and host that in their complete container. So that is the purpose of to separate every service in different containers. So that's the purpose of Docker.
Okay, nice contribution from your side. And so let me first tell you what is the Docker. Docker is an open platform for developing, shipping, and running applications. And Docker enables you to separate your applications from your infrastructure, so you can deliver software quickly. With Docker, you can manage your infrastructure in the same ways you manage your applications. by taking advantage of Docker's methodologies for shipping, testing, and deploying code quickly, you can significantly reduce the delay between writing code and running it in production, because you can check on the local system also. And Docker provides tooling and platform to manage the lifecycle of your containers. Because it's supporting containerization, and develop your application and it support components using containers. The container become the unit for distributing and testing your applications. When you are ready, deploy your application into your production environment as a container or an orchestrated services. This work is the same whether you are production or in a local system. And it's fast, consistent delivery for your applications. Docker streamlines the development lifecycle by allowing developers to work in standardized environment using local containers, which provide your applications and services. Containers are great for continuous integration and continuous delivery workflows. For example, a developer write code locally and share their work with their colleagues using Docker containers. They use Docker to push their applications into a test environment and execute automated and manual tests. When developers find bugs, they can fix them in development environment and redeploy them to the test environment for testing and validation. When testing is complete, getting the fix the customer is simple as pushing the updated image to the production environment. It provides a production environment in the local system. And it also allows us running more workloads on the same hardware. Because Docker is lightweight and fast, it provides a viable, cost-effective alternative to hypervisor-based virtual machines. It will be any virtual machine like a VirtualBox or etc. So you can use more of your computer capacity to achieve your business goals. And Docker is perfect for high-density environments and for small and medium deployments where you need to do more with fewer resources. Any question from the Docker? What is Docker?
No.
Next slide. Hello, am I audible?
Yes.
So this is the Docker. Docker architecture is also client server based, but it's a little bit more complicated than a virtual machine because of the features involved in it. It consists of three main parts: client, Docker host, and registry. And Docker client talk to the Docker daemon, which does the heavy lifting of building and running and distributing the Docker containers. The Docker client and daemon can run on the same system, or you can connect the Docker client to the remote Docker daemon. So what is Docker daemon? Docker daemon listens for Docker API requests and manage Docker objects such as images, containers, networks, and volumes. A daemon can also communicate with other daemons to manage Docker services. So we can say a background process responsible for receiving commands and the passing them to the containers command line. So it's another component is Docker client. The Docker client is the primary way that many Docker users interact with Docker. When you use commands such as Docker run, the client sends this command to the Docker, which carries them out. The Docker command uses the Docker API. The Docker client can communicate with more than one daemon. And this. So, and the next is the Docker registry, also known as the Docker hub. This is the location where the Docker images are stored, and it can be public Docker registry or private Docker registry. Docker hub is the default place of Docker images. It stores public registry. You can also create and run your private registry. When you use the Docker pull or Docker run command, the required images are pulled from your configured registry. When you use the Docker push command, your image is pushed to your configured registry same. And Docker host, also known as Docker object, when you use Docker, you are creating and using images, containers, networks, volumes. So first is the image. Docker images are the read-only binary templates used to create Docker containers. It is used as private container registry to to share container images within the enterprise, and also use public container registry to share container images with the whole world. And the metadata is also used by Docker images to describe the container abilities. It will also still means the Docker containers metadata. And you can create your own Docker images also using a Docker file. Create Docker file with all instructions to create Docker container and run it. It will create your custom Docker image. Next is containers. Container is a runnable instance of an image. You can create, stop, start, or move or delete a container. It's a lightweight and contain everything needed to run the application. So you do not need to rely on what is currently installed on the host, because it already it's all data related to runnable. You can easily share containers while you work, and be sure that everyone you share with gets the same container that work in the same way. And a container is defined by its image as well as any configuration options you provide to it. When you create or start it, when a container is removed, any changes to its state that are not stored in persistent storage disappear. So from the images you can, if you want to make a container from the images, you can run and it will create a container. And from containers you can run into in your browser. So next is the not in the image architecture, but in the image, but it's a volume known as the volumes. It's the persisting data generated by Docker and used by Docker containers are stored in volumes. They are completely managed by Docker through Docker CLI or Docker API. And network. In that we have mainly 5 types of networks. Like first is Bridge. It is the default network driver for a container. You use this network when your application is running on standalone containers. And the multiple containers communicating within same Docker host. So you can create multiple containers in same host. You can see in the image we have 4 containers in a single host. And next is the host. This driver removes the network isolation between Docker container and Docker host. And one is the none. This driver disable all networking, so we do not need to establish network before the creating image. So any confusion from the image of from the architecture of Docker?
Anyone? I think no one, brother.
Okay.
If there is in between, we will let you know. I am sharing my screen. Sorry for the inconvenience. Are you able to see my screen?
Yes.
Yes.
Yes, brother.
So here are some different host environments. First is a physical, and next is a virtual machines, and last is containers. So in first picture shows a physical machines or hardware. Typically when we build applications, we use resources provided by our host OS, and the same pattern used to follow when deploying the applications. But what if you want to scale the application? So what if you want to scale your application? At that time, what you will do? Then we need to increase our operating system capacity or our hardware capacity. And when build, at some point you might want another hardware server as the number keeps increasing. So does your cost and other resources like hardware and energy consumptions will increase if you are adding some extra hardware that it will cost, and also energy consumption. And then so After that, we have a virtual machine. In virtual machine, you can see in the second diagram, virtual machines have their guest OS, which is run over a single physical machine or host OS. So in that image, we can see we have a single hardware and multiple virtual machines. And in virtual machines, have an guest operating system. And after that, we have a run environment and an application. So we have two applications, two virtual machines, and two operating system. So it's running on single machine. Sometimes it's like if you are running first virtual machine, it will take all hardware. So at the time, what we will do second. So at the time we need to install numerous physical machines to distribute that load traffic and load balancing between the different virtual machines. So after that problems lead to next innovation known as the containerization. Unlike virtual machines, which were more operating system specific, containers are application specific, making them far lighter. Virtual machines can run multiple processes, where container run a single process. So in image, we can see we have a single hardware, single operating system, and multiple runtime environment, and we hosted multiple applications in single operating system. We have a guest OS, so sometimes we cannot directly directly can interact with hardware because of virtual machines. So in containers, we can directly interact with hardware because there is no guest OS. Differences. So now next is use of Docker with microservices. Organizations are increasing microservices because they not only want to be a large monolithic application, but they also want to enable faster app deployment and updates. Docker allows you to containerize your microservices and simplify the delivery and management of those microservices. And the containerization provides individual microservices with their own isolated workload environment, making them independent, deployable, and scalable. Docker Desktop and Docker Hub lets you standardize or automate the way you build, share, and run microservice-based applications across the organization. So it's already taken some storage for the run a particular container. So then raise the issue of the resources. And we can see Docker is like cup, or other words, containers, where microservice is the liquid for that cup, which will be poured in the cup. You can pour different types of liquids in the same cup. And Docker is lightweight, so it is best to keep one microservice per Docker container. So in the other hand, we have some microservice orchestrations in a Docker, like a Docker machine. You can ask to provide them a file and say, I need this container. They will help you to set up a Docker daemon, and you will be running the command lines as if you are somewhere on the ground, like as you are providing the Docker. And next is the Docker Composer. In that you will need it where you have one or more containers that support one use case. It allows you to define all your images and containers. It defines various ports or areas where containers can talk to each other. And using Docker machines, you can run this on the cloud. It's much useful for our microservices. If you have a multiple microservices for a simple application, so you can compose that with a single YML file. And inside that you can define port for all the microservices, and you can host on that Docker event. One single Docker machine, so they can communicate with each other by the defined port. Hello. Any question from audience side related to Docker?
So thanks for the wonderful session, Pradeep. Now we are open for the discussion, guys. If you want to discuss anything regarding the microservices or the .NET, now we are open to discuss here. It is not mandatory that only speakers have to answer that question. Anyone, if there, anyone have an experience about that, they can.
Rohit has question like how Dockers communicate to each other.
Hello.
Yes, Pradeep, you are audible.
Docker hosts our services. It doesn't communicate with each other. Assume you have one Docker, we have a 4 container, like 4 services. So once you request something, if you want to access some data from the container 2, so there will be port defined for all the containers. Let's if our one container is running on the port number 5001 and second was the port number 5002. So from here we will request. So where we will set the endpoint of port container 2, like other REST APIs, we have set the endpoints. So where we will request to be sent. So it will send request to the port 5002 port, and from there we can, and we are using for communication any protocol we can use. Thanks, Salman, for your answers. Docker is the host. Docker is used for hosting, not the communication. For communication we have a gRPC, Kafka, Event Bus, RabbitMQ, etc.
Anyone else?
I want to share something. I have shared my screen. Sorry to interrupt. I think it's a very important part to discuss about event bus. So I just took over this one slide and want to go a bit deep. So the other can like have any questions that they can ask. Okay. So as already discussed previously in the sessions, like you can see this image, right? So many one have question like what are the ways to each services which can communicate with other one. Like as we know, like there are many services which are dependent and some operations among the services which need to be connected in any way, right? So in that case, there are I can say two ways where we can do. First thing is like you can use services as a part of connected service to other service. If I talking about .NET architecture, so Visual Studio provides the communication like where we can register any other services with the any other services, and we can use some services from each other. Okay, but the different thing and the what most important thing is like the bus service. Okay, so there are for now I have three different like tools where we can use as a Azure bus service. So I have written down some points over here. So in event bus, what there are various ways to communicate with each another services, and in that there are few I have listed over here. The one is publish subscribe, second one is the routing, and third one is the topics, and there are many others as well where the ways we can communicate with each other like services. I do not go in details, but I just want to point out some points like how we can write down our logic or what tools we need to use in which situation for event bus architecture. And there are some tools like Kafka, RabbitMQ, and Azure Bus Services, and each one of them have a different capabilities. You can use any one of them or multiples also. You can do multiple tools at the same time as well. You just have to write a different logic for the same, and you can use it. So I have like researched something. I have some links. I will paste it over chat as well. So here a few like things. Like as I said, there are some tools. So Kafka is basically like based on publish and subscribe logic for Azure Bus Service. So what it will does is like when any service when put any data to a service bus, the other services which are subscribed to that particular task or a service, they are receiving whenever any data is pushed by any services. So on that logic or a architecture, you can use Kafka. For Azure bus service, we have like as I can say as you can see this Microsoft document. It's basically works as a queue, and as I said, like there are many ways: public subscription, public pub sub architecture, and the queue and the topics and many more. So Azure bus service is most mainly working on the queue part, and this is the architecture where you can get all idea. Obviously, I'm just here to point out some topics. I'm not going to deep, but if you suggest as a feedback, and then we can also come with the deep understanding of how bus services will work and communicate with each other services. Okay, and the third one is the RabbitMQ, which have a large, you can say, ways to communicate with each services. There, those are described over here. As I said, there is one pub sub and the working queues. We have routing as well. We have topics as well. As I said earlier, like we can use one service to the another service as a RPC server and the other things, and one is also the publisher confirm. So there are many ways also, all the tutorials and the installation guide, and also they have provided some documentation with the C# language as well, so you can go to these things. So yes, if anything in this, like you have any question, you can raise over here.
You can ask your question here. Thank you so much, Akhtar Ali, for sharing knowledge. Anyone else want to share anything?
Yes, as of the second part, we will go with a demo of microservices with .NET, with coding architecture and all of the things, and how all things will be going to communicate with each other. And also we will go with bus service architecture and the logic, how we will write and how we will need to subscribe all of the things. So yes, Sek, we will come up with the next meetup in mostly in the next month with the .NET integration. So basically, we tried to differentiate our meetup in the two parts. Where in the first meetup we discuss all of the basic or document related stuff, like what is microservice and understand why it is required, and what are the main things. So, like in which situation we need to use microservice and we need to go with a monolithic architecture, and what will be the price effect and all the things. But in the next meetup, we go come up with the Visual Studio demo project, where we can create project, how to create protofiles, how to create service files, what kind of databases we can use, how to communicate with each services, event bus architecture logic, also with the .NET 6, which we have a privilege to .NET support with the community. So we will come up with the next meetup and we will include those all the things with the demo part. So yes, Sek, that was a good thing. Uh, Manhar, I guess there are some chat in the chat box. Please look at the same. Even you can speak more by unmuting yourself, and you can share some points which we haven't covered in this slide, but we need to discuss related to the microservice, or also you can give feedbacks to us, like how we can improve more, and we can come up with the next idea with the good uh, knowledge base. So I'm looking forward to hear from you guys. So yes.
Hello, am I audible?
Yes, you did.
Yes, yes.
There are few points actually. First of all, while we are talking about microservices, so we should have some some real working example of
Yes.
the microservices so that we can relate it to
Yes.
what we are learning actually.
Yes. Sure.
As of now, we just gone through the theoretical part.
Yes. Yes.
So we are relating, but if we see something running,
Yeah.
then we can definitely relate it to what is going on.
Yes.
Correct.
So as of
So
the example, thank you for the like great question. I can say, yes, obviously we haven't gone through our like working environment and working development, but I want to share one example what in the already in the real time market available. Okay, so there are many e-commerce websites. So for example, if I took Amazon website, right? So what is happen is there is a different services for managing cart, managing products, managing orders, and the delivery part, etc. Okay. So what is happen is you if you notice the cart is only working on the browser side, right? So whenever you add any item to the cart, it's just adding to cart and showing on the checkout page. Okay, so in that case your login is not required and many things that you not required when you just watching the products and you're just adding the cart. So in that case there is a service differently working for a cart management. So in that case they are using a redis or a in-memory database or a browser database, where they are whenever you click on the product they are just adding to the database and showing to the add to cart page. So the different service working for a cart service. The next service is the order service. So for order service you need to go for a login. So account service is only managing login and registration part, and the order service is managing the order part. So all the order related stuff like what product, what are the pricing, the address services, and all the things will be managed by the order server. So as of now I can say like many or more current existing e-commerce large e-commerce websites are in the microservice, and you can say there are the applications of microservice. So the actually what is like the main advantage of using microservices, like as you know, like when in Diwali coming or any occasions or festivals coming in the India, there are many offers and the deals are released by the particular brands, and they are basically fighting like Great Indian Festival and many more things which are going through, and we are getting most of the discounts, and they are running sale. And then so in that case, if you think like if you go with a monolithic architecture, and in that occasions suppose there is a huge traffic on particular time span, so how they are managing the things? So they are like as of now they created a microservice. So what happens, so whenever any server load increases to particular service, they just update or increase the server capabilities for that particular service only. So what it will help to, like they will not affect the other services. So suppose any server got a high ping and it crashes, but other services will work and you can still access the products even if you are not able to do the order. So in that architecture they are working on the microservices. But suppose it is in the monolithic architecture where all of the code are put it over here on the same bucket, and if it crash then website will be crash. Sometimes it happens like you can not order, or sale ends, and there are many things, pricing changes. It all because of microservice where it will working as a independent lines where it will not dependent to each other. And yes, uh, I must say like best example for microservices are the e-commerce for now. Yes, but in
And
yes,
Ali,
yes,
yeah. Uh, I guess ask this question is Rohit, right?
I guess Rohit and also Mezam, I guess.
Yeah.
Yes, yes.
So, like for code related part and like how to organize all the projects and codes in a microservice architecture. So all that related stuff we are explaining in next meetup with detailing. So I guess that is good for you, and also like if you need to join that.
Yeah, yes, yes. Thank you.
Just still, if you have anything that you want to discuss. Actually, that was a very good question, and I wanted that kind of questions so we can like discuss those things. Yes, as of the part of meetup, we are here to share information, and we gain some information from you guys as well. So yeah, I'm willing to have some more questions from you.
Yes.
Hello.
Yes,
Yes.
Yeah, this is Abhishek here.
yes, Abhishek.
So I think, yeah, the presentation was quite good. So in the next meeting, I think, see, for those who are starting just on Docker and microservices, I think the important thing is that first you understand what is Docker. It is a containerization platform, and the other thing is microservices, right? So I think Salman just shared one of the example of e-commerce application, and he's right, because in many of e-commerce applications, lot of services they have written and they are scaling individually. But while you are learning microservices, it's also important that where use case where you can use microservices. Microservice is not something like a new tool or SDK, and you can use it anywhere, right? You
Yes,
need to
This is
find
one
a right
aspect.
use case. Yes, you need to find a right use case, because you need to understand the pros and cons of microservices. For example, let's say just an example, let's say there is an e-commerce solution and you have developed, for example, dozens of microservices, right? Now,
yes,
let's say every microservice has its own database, right?
yes,
Now, when you are creating a new transactions, imagine you have to create records among different database, right?
yes,
Now,
Yes.
what happens when you want to roll back the transactions? It is a very cumbersome processes, and that's where the distributed transactions comes into the picture. Now, how to cope up with distributed transition? That is another pain. That is another complexity. And there are even patterns and tools are available to solve that. Like a Saga is one of the pattern. Two-phase commit is one of the pattern. So what I'm trying to say is that first understand the core part of what exactly the microservices is, and then find the real use case where you can actually use it.
yes,
Of course, for learning, it is nice. It is really good, but don't jump in to implement it everywhere. Right?
yes,
That is very
yes,
Yes.
important.
That it's like depend on like requirement. If and like how many users will come after the developing and after the release your product.
Mhm.
That's depending on that. Like I guess.
Exactly, exactly.
yes,
And Docker is a containerization solutions. But when you want to, when you want to orchestrate all your containerizer platform, then it comes to use of Kubernetes or Docker Swarm.
yes,
Yes. Yes.
So, right.
yes,
So
Yes.
yeah,
Yes,
In a we are already like implement Kubernetes in a current projects because without Kubernetes load balancing and all that thing is not uh, easily managed on directly on Docker. So I
exactly.
guess this is good tool for load balancing and all that things.
You're right, right.
yes, Abhishek. I understand your point. So we also try to add one use case, like in which case you need to use a microservice architecture or go with a monolithic one. So
Right, right.
basically, it's
No,
basically it depend. Yes, yes,
no, no. What I'm saying is that learning everything is good, but as a developer, being a tech
yes,
lead or an architect, we really need to understand what is the use case. And
And
you need to basically follow the polyglot pattern, right? So,
yes,
for example, if one problem is solved by one tool or one pattern, solve it, but don't solve the another problem with the same tool and same pattern, right? Because the use case can be different.
yes.
yes, yes,
Yes.
yes.
Yeah.
Thank you, Abhishek,
Thank you, Abhishek.
for
Sure.
It was a
sharing this
very
kind of
interesting
information.
feedback.
Thank you. Okay. Anyone need to share anything related to microservice or anything like if you have any question related to .NET technology and all.
So, Mazam and Salman, I have been working in this microservices and Kubernetes and Docker from
Great.
extensive years of experience I have in it. So even for
Okay.
the next session, if you really need any help, you can
Yes,
Okay.
definitely reach to me, and I would love to help.
sure.
Sure. So thank you. Thank you for this kind of like you can share your contact and your email ID on a feedback form so we can easily you can contact.
Yeah, no problem. I will do.
Even we try
Okay.
to have your one. like session with our in our next meetup, so other
Yeah.
guys can have a expertise information to us as well. Like even we are in the beginner for our microservices, we just wanted actually this was the main reason why we do meetups. So
Yeah. So
Okay.
the
in
main moral of meetup is transferring the knowledge each other.
Exactly. So what I can do is, because I know how to write microservices architecture with Docker and Kubernetes on .NET, because I have been into .NET for many, many years. So what I can do, because I have created so many examples, so I can share one of the example with you, how exactly you can start with Docker, how exactly you can, write application on .NET with Docker, how exactly you can deploy on Kubernetes, and how can actually scale and scale down. So I think that would give a tremendous experience and knowledge to audience. I mean, that I
yes,
can do, maybe
yes, yes,
whenever you wish.
yes, sure, it will help a
Okay.
lot. It will help a lot.
Uh, okay. We will discuss it on personal. You can send me a message on LinkedIn also. My name is Akash Limbani, and senior
Okay,
.NET developer at Yudiz.
no problem, no problem. Yeah, I would
Yeah.
definitely love to help community. So,
Yeah. Thank you,
Yes,
Abhishek.
thank you, Abhishek. Thank you
sure,
all. Bye.
most welcome. Yeah.
Okay, so that's it from our side. Like, if to share anything, let me know, or else we will conclude and complete this meetup. Okay, so right now we will end up this meetup, and thank you for connecting here and sharing your knowledge. Thanks a lot. Have a good day.
Once again, thank you so much, guys, for joining.
Thank you
Bye.
guys. Thank you
Bye
guys
to
for
everyone.
enabling us to meet fellow .NET developers. Thank you.
Yes.